February 2021, Texas. The worst winter storm in a generation has just ripped through the state. Millions of homes lose power. Pipes freeze solid, then burst as temperatures swing back above freezing. When the water comes back on, homeowners across Houston, Dallas, and San Antonio discover the same nightmare. Every drain in the house is backed up. Grease that has been silently building inside kitchen pipes for years has now hardened into concrete-like plugs. Plumbers are booked out for weeks. Emergency call-out fees spike to $500, sometimes more. Hardware stores sell out of chemical drain cleaners within hours. Desperate families are posting on social media, asking strangers for help. And then, buried deep in the comment sections, a quiet pattern emerges. Grandmothers in rural Texas start sharing the same advice, almost word for word. Boil a kettle, grab the baking soda from the pantry, pour some vinegar down the drain. One woman in Lubbock posts a video of her kitchen sink draining freely after 10 minutes. Her total cost? About 40 cents. Here is the strange part. That 40-cent method is not some fringe internet hack. It is one of the oldest chemical cleaning techniques in recorded history. Variations of it were used to maintain the water systems of the Roman Empire. It was common knowledge in every American farmhouse 100 years ago. Your great-grandmother almost certainly knew it by heart. So why don't you? The answer is not a conspiracy. Nobody held a secret meeting to erase this knowledge from your brain. The answer is something more ordinary and, honestly, more interesting: economics. When a solution costs $1 and cannot be patented, no corporation on earth has a reason to advertise it. But when a branded bottle of chemical gel costs $15 and needs to be repurchased every few months, suddenly there are billions of reasons to make sure that bottle is the only thing you see on the shelf. Welcome back to Historia Prime. Today we are going deep into the hidden history of your plumbing. We will trace a chemical discovery from the marble aqueducts of ancient Rome to a breakthrough in an 18th century French laboratory, and then straight into the pipes underneath your kitchen sink. By the end of this video, you will understand exactly how clogs form, why commercial drain cleaners are far more dangerous than you think, and how to maintain every drain in your home for less than $1 a month. Let's begin. Part 1. The Roman Secret. 2,000 years ago, the engineers of Rome faced a problem that would sound very familiar to any modern homeowner. Their aqueducts, hundreds of miles of stone channels carrying fresh water to public baths, fountains, and private villas, were slowly choking themselves to death. The culprit was calcium carbonate, hard water flowing through marble and limestone channels, left behind a thick, stubborn mineral scale, layer by layer, month by month, gradually narrowing the flow until entire sections went dry. No high-pressure water jets, no synthetic chemicals, no hardware store down the road. So what did they do? They reached for sour wine. Specifically, wine that had turned, what we now call vinegar. Roman engineers discovered that when they poured amphorae of this acidic liquid into the clogged channels, something remarkable happened. The acetic acid in the vinegar reacted with the calcium carbonate scale, dissolving it. The mineral deposits broke apart. Water flowed again. Think about that for a moment. The first half of our $1 drain solution was already being used as infrastructure maintenance technology 2 millennia ago, keeping the water systems of the greatest empire on Earth running. This was not folk wisdom or superstition. This was applied chemistry, centuries before anyone had a word for it. Part 2. The French powder that changed everything. Now let us jump forward about 1800 years to the laboratories of revolutionary France. In 1791, a chemist named Nicolas Leblanc invented a process to produce synthetic soda ash on an industrial scale. One of the byproducts of his method was a fine white powder, sodium bicarbonate. You know it as baking soda. Within decades, households across Europe discovered that this cheap powder could do extraordinary things. It scoured surfaces clean. It neutralized the foul odors that plagued kitchens and washrooms in an era before modern sanitation. It preserved food. But the real breakthrough came when someone, history does not record exactly who, tried mixing it with heated vinegar in a clogged wash basin. The result was dramatic. A violent, foaming chemical reaction erupted. The fizzing mass forced its way into the pipe, and the blockage cleared. By the mid-1800s, keeping a tin of bicarbonate beside the kitchen stove was as standard as keeping salt on the table, at least in most of Europe. Then, in 1903, a Belgian chemist named Ernest Solvay perfected a far more efficient industrial process for producing baking soda. The cost of the powder collapsed. Factories gave away sample bags. Hardware stores across rural America stacked cheap boxes of bicarbonate right next to gallon jugs of white vinegar. The two products sat side by side on the same shelf for decades, and the knowledge spread everywhere. Farmers used the foaming reaction to clear clogged irrigation lines. Ranch hands poured it down livestock trough drains after winter freezes. Miners in Colorado kept barrels of both compounds to maintain water flow in deep tunnels. When a pipe clogged, nobody panicked. Nobody called anyone. It was a 30-minute chore that cost less than a penny. That was the golden age of household self-reliance. A clogged drain was no more frightening than a squeaky door hinge. You understood your own home, and your home cooperated. So what changed? Part 3. How the market buried a $1 fix. To understand how an entire generation forgot what their grandparents knew by heart, we do not need a conspiracy theory. We just need to follow the money. In 1923, a company called Clorox started selling sodium hypochlorite bleach in amber glass bottles out of Oakland, California. Within a decade, the chemical industry had figured out a powerful economic formula. Take a simple, dirt-cheap compound, put it in a branded plastic bottle with a dramatic label, and sell it for 40 times the raw material cost. The first commercial drain cleaner hit store shelves around 1925. Its active ingredient was sodium hydroxide, commonly known as lye, a substance that costs pennies to manufacture in industrial quantities. But packaged in a branded bottle with a skull and crossbones warning label, the retail price represented a markup of several thousand%. Now, let me be fair here. These commercial products do work. Lye is a genuinely powerful chemical that can dissolve organic matter. Professional plumbers provide a real, valuable service, especially for serious plumbing emergencies. Nobody is arguing that the entire industry is a scam. The issue is not that these products and services exist. The issue is proportion. Today, the American plumbing services industry generates well over $100 billion annually. The commercial drain cleaner market alone is worth billions. Products like Drano and Liquid Plumber dominate supermarket shelf space. The average emergency plumber visit for a clogged kitchen sink runs between $200 and $500. Meanwhile, a box of baking soda costs about $1. A gallon of white vinegar costs about $3. Neither product can be patented. Neither product has a marketing budget. Neither product has a sales team, a jingle, a television commercial, or a sponsored segment on a home renovation show. And that is the entire explanation. The $1 solution was never disproven. No study ever showed it was dangerous or ineffective for routine maintenance. It was simply out-marketed. When the only products with advertising budgets are the expensive ones, the cheap solution quietly disappears from the cultural memory. Not because someone decided to hide it, but because no one had a financial incentive to remind you it existed. This is a pattern that repeats across dozens of industries, by the way. Whenever a cheap, unpatentable solution competes with an expensive, brandable one, the branded product wins the shelf space every single time. It is not malice, it is just how consumer markets work. But the result for ordinary people is the same. You end up paying $15 for something your pantry could have handled for a few cents. Part 4. Inside the pipe, the anatomy of a clog. Before we get to the practical guide, we need to understand the enemy, because not all clogs are created equal, and the reason most people fail with home remedies is that they treat every clog the same way. Let us start with the kitchen sink, where the most common villain has a name in the plumbing industry: the fog clog. FOG stands for fats, oils, and grease. Here is how it works. When you cook bacon, roast a chicken, or wash a buttery pan, the hot liquid grease slides easily down the drain. But as it travels through your pipes, it cools. And as it cools, it solidifies. It clings to the inner walls of the pipe like candle wax hardening inside a glass tube. Over time, this sticky layer traps food particles, coffee grounds, and other debris. Layer by layer, month by month, the pipe narrows. Eventually, it chokes shut completely. In the bathroom, the enemy is entirely different. It is a brutal combination of human hair and soap scum. Hair does not dissolve easily in anything short of a strong acid. It acts like a net, catching the sticky residue of soap, toothpaste, and dead skin cells until a dense, tangled mass blocks the drain. But there is a third enemy hiding in every drain in your house, and this one is genuinely fascinating. It is called a biofilm. A biofilm is not just dirt or grime. It is a complex, living colony of microorganisms, bacteria, fungi, and the slimy matrix of polymers they produce to anchor themselves to surfaces. Picture a microscopic city, complete with infrastructure, clinging to the inside of your pipe. Biofilms are the structural glue that holds clogs together. They are also the source of those foul, rotten egg odors that sometimes drift up from the drain. In hospital settings, drain biofilms have been found to harbor genuinely dangerous pathogens. In a household setting, the risks are far lower, but the principle is the same. Biofilms make everything worse. They make clogs stickier, smellier, and harder to remove. Understanding these three distinct enemies, grease, hair, and biofilm, is the key to understanding why one single method cannot solve everything, and why the approach your grandmother used was actually far more sophisticated than it first appears. Part 5. The real science. What actually happens in your drain. Now we arrive at the heart of the story, and I have to be honest with you here, because the popular version of this method, the one you see in countless internet life hack videos, gets something fundamentally wrong. The popular myth goes like this: mix baking soda and vinegar, watch the dramatic fizzing eruption, and that explosive pressure blasts through your clog like a chemical bomb. It looks spectacular, it looks like science, and it is deeply misleading. Here is what actually happens. When sodium bicarbonate meets acetic acid, a chemical reaction produces three things: sodium acetate, water, and a large volume of carbon dioxide gas. That gas is what creates the impressive fizzing. But here is the problem. Your home plumbing system is not a sealed pressure vessel. It is an open system designed with vent stacks that run up through your walls to the roof, specifically to allow gases to escape safely. The carbon dioxide simply takes the path of least resistance and vents upward. It does not build up enough pressure to blast through a wall of hardened grease. And there is a second problem. When you mix an acid with a base, they neutralize each other. The resulting liquid, sodium acetate in water, is essentially slightly salty water. It does not have the chemical power to dissolve hair or break down thick grease. So if the fizzing does not create a pressure bomb and the resulting liquid is basically salt water, why did generations of farmers, miners, and housewives swear by this method? Were they all wrong? No, they were right, but not for the reason most people think. The secret is that the method works in two stages, and the second stage is the one that modern internet tutorials almost always leave out. Stage 1. The baking soda and vinegar reaction. The fizzing action of the carbon dioxide bubbles is genuinely effective at one specific thing: mechanically scrubbing away biofilms and deodorizing the pipe. The bubbles physically disrupt those microbial colonies we talked about, breaking them loose from the pipe walls before they can anchor larger clogs. Scientific research published in microbiology journals has shown that bicarbonate is surprisingly effective at inhibiting bacterial growth and preventing biofilm formation. It disrupts the chemical signaling that bacteria use to organize into colonies. So when you pour baking soda down your drain, you are conducting microscopic biological warfare against the very organism that holds clogs together. But the real hero of the process, the step that actually clears a grease clog, is stage 2, the hot water flush. After the fizzing stopped, your grandmother never just walked away. She always finished with a full kettle of boiling water poured slowly down the drain. This is where the actual physics happens. The extreme heat melts the solidified fats, oils, and grease back into liquid form. Add a few drops of ordinary dish soap, a surfactant, and the soap molecules wrap around the melted grease, trapping it in the water and allowing the whole mess to flush away into the main sewer line. The $1 method is not a single magic potion. It is a strategic two-stage process: biological disruption and deodorizing with baking soda and vinegar, followed by thermal melting and chemical emulsification with boiling water and soap. Each stage targets a different part of the problem. Together, they are devastatingly effective for routine household maintenance. Part 6. What commercial cleaners actually do to your home. At this point, you might be thinking, this is interesting history, but commercial drain cleaners are faster and easier. Why not just use those? Fair question. Let me walk you through what actually happens inside your pipes when you pour a commercial cleaner down the drain. Most commercial drain cleaners rely on sodium hydroxide, lye, or sulfuric acid. These chemicals dissolve organic matter through extremely aggressive reactions. Lye, for instance, works through a process called saponification. It literally converts grease into soap. To do this, it generates an intensely exothermic reaction. The temperature inside your pipe can surge past 200 degrees Fahrenheit almost instantly. Here is where the problems start. Standard PVC plastic pipes, the white pipes in most homes built after the 1970s, are typically rated for a maximum of 140 degrees. When lye pushes temperatures well past that limit, the plastic can warp, soften, and eventually fail at the joints. If you live in an older home with galvanized steel or cast iron pipes, the caustic chemicals corrode the metal over time, thinning the pipe walls and creating the conditions for hidden leaks behind your walls, the kind that lead to mold growth and repair bills in the thousands. There is also a genuine household safety risk that most people are never warned about. If you use a bleach-based cleaner on one occasion and an ammonia-based cleaner on another, or worse, if residue from one is still in the pipe when you pour in the other, the two chemicals can react to produce chloramine gas. Chloramine is a toxic irritant that causes severe respiratory distress, burning eyes, and in concentrated doses can send you to the emergency room. It is not a theoretical risk. Poison control centers across America receive thousands of calls every year from accidental chemical mixing in household drains. And there is a final irony here. Many professional plumbers privately dislike commercial drain cleaners. When a plumber arrives at your house to fix a clog that a chemical product failed to clear, they have to open a pipe that is now filled with a hot, corrosive chemical stew. It is a genuine occupational hazard. None of this means commercial cleaners are useless. For severe, one-time blockages, they can be effective. But for routine maintenance, the kind of regular upkeep that prevents most clogs from ever forming in the first place, they are overkill. It is like using a flamethrower to light a birthday candle. The tool works technically, but the cost and the collateral damage are completely out of proportion to the problem. Part 7. Your Survival Guide. A different tool for each enemy. Here is where we put everything together. Remember, not all clogs are the same, and each type requires a different approach. The genius of the old method is that it was never a single trick. It was a toolkit. Let me walk you through each scenario. The kitchen sink, defeating the fog clog. If your kitchen sink is draining slowly, you are almost certainly dealing with solidified grease. For this enemy, the primary weapon is heat, not fizz. Boil a large pot of water on the stove until it reaches a full rolling boil. While you wait, squeeze a generous tablespoon of grease-cutting liquid dish soap directly into the drain opening. The soap is your surfactant. It will bind to the grease molecules and allow the water to carry them away. Now, carefully and slowly, pour the boiling water into the drain. The heat melts the fat. The soap traps it. The water flushes it. For a stubborn, slow-draining sink, repeat this process 2 or 3 times. In most cases, that is all you need. The bathroom drain. Hair and soap scum. Hair is made of keratin, a tough structural protein. No amount of baking soda, vinegar, or hot water will dissolve it. For hair clogs, you need physical intervention. A $2 plastic drain snake with barbed hooks, or even a straightened wire coat hanger, will pull the hair mass out in seconds. But hair is usually tangled up in a matrix of soap scum and mineral deposits. And this is where we summon the ancient Roman secret. After removing the hair, pour a cup of heated white vinegar down the drain. The acetic acid will dissolve the calcium carbonate and soap residue, exactly the same chemistry that cleaned limestone from Roman aqueducts 2,000 years ago. Let it work for an hour, then flush with hot water. Your pipes will run like new. Monthly maintenance, stopping clogs before they start. This is where the famous baking soda and vinegar combination truly shines, not as an emergency fix, but as a preventive maintenance ritual. Once a month, pour half a cup of dry baking soda into every drain in your house. Follow it immediately with half a cup of white distilled vinegar. As the fizzing erupts, quickly cover the drain with a wet cloth or rubber stopper to direct the scrubbing action downward into the pipe. The reaction disrupts biofilms, neutralizes odor-causing acids, and inhibits bacterial colonies from establishing themselves. Let the mixture sit undisturbed for 30 minutes, then flush with a kettle of hot water. The total cost of monthly preventive maintenance for your entire house, less than $1. Compare that to a single emergency plumber visit that averages $300, or a year of commercial drain products that can easily exceed $150. When to call a professional? I want to be completely straightforward with you, because credibility matters more than a dramatic narrative. If multiple drains in your house are backing up at the same time, the kitchen sink and the shower and the toilet, you almost certainly have a blockage in your main sewer line. This is often caused by tree roots that have invaded the underground pipe. No amount of baking soda and vinegar will clear a living tree root. For that, you genuinely need a professional with a mechanical auger or hydrojetting equipment. The $1 method handles roughly 90% of everyday routine household clogs, the soft organic matter in your kitchen and bathroom. For the other 10%, a professional plumber is worth every dollar. The goal here is not to never call a plumber again. The goal is to stop calling a plumber for problems your pantry can solve. History is not just the story of kings and empires, wars and treaties. History is also the story of how ordinary people kept their homes running, their families healthy, and their problems manageable with whatever they had on hand. The Romans cleaned their aqueducts with sour wine. A French chemist gave us a miraculous white powder. American farmers and miners combined the two and kept their water flowing through some of the harshest conditions on the continent. For centuries, this knowledge was as ordinary as knowing how to boil an egg. Then consumer culture did what consumer culture always does. It replaced knowledge with products. Not through a conspiracy, not through a cover-up, just through the quiet, relentless logic of profit margins and shelf space. The cheapest solution does not get advertised. The solution that cannot be branded does not get a place on the shelf. And within a generation, common knowledge becomes lost knowledge. But you know it now. Remember that family in Texas during the 2021 freeze? Pipes burst, plumbers booked for weeks, hardware stores empty. Some families spent hundreds of dollars waiting for help that never came. Others walked to the kitchen, boiled a kettle, and fixed it themselves in 10 minutes for less than the cost of a postage stamp. The difference between those two families was not money. It was not luck. It was knowledge. The kind of knowledge that has been right there in your pantry this entire time, waiting quietly for you to remember it. So the next time your sink backs up, do not panic. Do not reach for your wallet. Walk to the pantry, put the kettle on, and let a little bit of ancient history do the work. You cannot patent a box of baking soda, you cannot brand a gallon of vinegar, and you cannot charge $300 for a solution that costs 40 cents. That is exactly why they stopped reminding you it existed. Thank you for watching. If this video changed how you think about your home, share it with someone who is still paying hundreds for a clogged sink. Subscribe to Historia Prime so you never miss another piece of lost knowledge. And tell me in the comments, what other forgotten survival skills do you want us to dig up next? Until next time, keep questioning, keep learning, and keep history alive in your own home.